I was stuck on some. What? How did we figure out? Okay, the probability. I was trying to figure out because on number 15, what is the probability that your random 100 adults will have a sample proportion less than 0.25? Now, that's where we use the normal probability app, correct?
Yeah, you have to, let's see. So
because
number
I want to say I put number
gave you the mean, and then number 12 gave you the standard deviation.
the standard deviation.
And then you have to use both of those to find the z-score, and then plug that into the
okay, that's what I didn't do. I didn't find the z-score. Because I was like, I cannot remember how the heck to do this.
Yeah.
Okay. And
do you guys know if there's a way I can turn up the volume on this? You guys are like really quiet.
It's because Erica turned it down. She turned our audio down.
Oh, gotcha.
I kept seeing it pop up, and I'm like, oh, what's going on? Okay. Standard deviation and the mean. Oh, and you know that flow chart that I was mentioning was in the video that I wish we had? I emailed her and asked her. It's in resources.
Okay. Oh, awesome.
But it's not filled out. I just
copied the notes of it after you told me about it. I went and watched it and copied it down. But that's even better if it's in the resources.
I couldn't necessarily read it. So it's the statistical flow chart. And the only thing that I did was I got down to, I didn't put anything in the details. I just finished filling out like the one sample, like sigma known, it's one sample Z test, sigma unknown, it's a one sample T test, and all of that. And so that's all the farther that my dog is spazzing out. Must be a puppuccino that I gave him. Have you guys seen that, the puppuccinos? Dutch Brothers. They give out puppuccinos. I don't know if you guys have been to Dutch. Like most everybody has gone to Dutch Brothers, but they have really good Italian sodas, and like I'll do almond milk steamers, like pumpkin almond milk steamers around Thanksgiving and stuff. But they'll put whipped cream in a little tiny cup, and they'll fill the whole thing with whipped cream, and they'll put like 2 dog biscuits on the top of it.
Oh, that's cute.
And so it's a puppuccino, and I put the lid on it, and I wouldn't let him have it until he got back here, and I think the sugar and the whipped cream has got him hyper. Like a kid.
Where are the resources you were talking about?
Okay, if you go to content, and on the left-hand side, it's all the way down below. The file is all the way down below the final project. It says resources. You click on that, and there's 2 different ones. There's statistics methods table that isn't filled out, which allows us to put the requirements next to it. So like a one mean, I can't talk, sigma known. What are the requirements? And the confidence interval computation method. So I'm guessing that's the, the confidence, I don't know, the formula, I don't know. And then the hypothesis test, the null and the alternative, the computation method, and then like the test statistics, whether it's going to be a T or a Z, and the miscellaneous information. I don't know if, I'd say let's eventually, like before the final exam, we could take time and work together to fill it out, but I don't know what we'll be able to use. I'm stressed. Our exam has to be finished tomorrow.
Yeah.
Oh my heavens.
On the Google sheet that you sent us, are we, so I thought we were doing an ANOVA test.
Oh, you know what? Yeah, sorry. I sent that one. I sent the wrong one to you. Let me. Yep. Okay. Sorry. Hold
You're
on
good.
just a second. We could actually use this while we're doing our our other one. Let me. Which one? Okay, let me see. I gotta see which one is quantitative inference procedures. It's gotta be that one. I'm glad you pointed that out because I didn't even look. I just like, oh, this is the one we're working on. So. The file is too large. Seriously.
Oh no.
Let me see. Let me see if I can upload it specifically to Google Sheets.
Yeah.
So strange. Oh my God. Sorry, hold on. There you go. I wonder, dang it. If we copy and paste, I don't know if it'll copy and paste the formula.
Oh.
Let me go down a little ways. And I'll see if I can copy and paste the formula into. It doesn't, dang it. Do you know how to copy and paste with all the formulas?
I think they should just copy over, but I don't know what to do if they're not.
I would think so too, but it didn't.
That one I've tried. I think. I'm trying to think which one. I've tried to do it, and I was surprised you got the other one on there because I've tried the ANOVA one.
I didn't copy and paste on that one. I actually went into Google Docs and or Google Drive. I uploaded it onto my Google Drive, so I had it there. And then okay, hold on. I don't know how. Let me see if I can. Oh, shoot. It must have over 2 million cells because the spreadsheet, it says up to 2 million cells. These are the file sizes for spreadsheets, up to 2 million cells for spreadsheets that are created in or converted to Google Sheets.
Holy cow.
Yeah. So I don't know. That's so crazy because let me see.
It's the quantitative inference one, right?
Yeah. And I would say paste special, but paste values only, paste format only. No.
And mine won't let me convert it to a Google Sheets document.
Yeah, neither will mine.
I even tried it on my new iPad, and it won't let me.
I think we might just have to put our data in the spreadsheet and then copy it over individually to the one that she gave us in the quantitative inference.
What we can do, if you want to do it that way, then we can still, I'm looking to see if we can, but click on the cell to be propagated and copy it. Select the cells you want to. So it should, let me see, I don't know why.
You could still do it. Could you share it from Google Docs as an Excel spreadsheet instead of a?
Well, this is, I'm gonna share it this way anyways.
The only concern I have is that if it stays as an Excel spreadsheet, it's a template, and so every time you close it, it doesn't save the data. Have you ever noticed that? Like it just comes back with the same data in it.
It should automatically save. I guess I can test it out, but I'm going to go ahead because I copied and pasted. And so I'm going to go ahead and see. I sent it. Because it doesn't. Yeah. For some reason, the formula doesn't change, but so we're gonna. What are the colors in? We can utilize this spreadsheet and we can enter it in, so we're all working in the same spot, and then we can copy and paste just the numbers over, I guess.
Okay. Yeah.
Yeah, that would work.
Green, red, yellow, blue, brown. Is that all of them?
Green, red.
Dog.
I think that's it. Seems.
Bandit. Darn it. I'm going to try one other thing.
Looks like there's an orange too.
Oh, yep. Okay.
I just looked up the colors and I came up with, I guess, some statistics someone else has done where it's a breakdown of the percentages of each color of M&Ms.
Oh.
So like 30% brown, 20% yellow, 20% red, 10% orange, 10% green, and 10% blue in M&M's milk chocolate. Peanuts, 20% brown, 20% yellow, 20% blue, 20% red, 10% orange, and 10% green.
Interesting.
Are you stuck? Oh, you are. That's why you're mad. There you go. My dog clotheslined himself earlier. He's running around in the living room and like back past my love seat through the living room and around through the kitchen, because you can go from the living room to the kitchen and circle around. And he's hauling butt through the kitchen and coming around, and his leash flipped, because I have his leash on because he's a puppy, so I can stop him if he's running away from me and he's got something. Anyways, his leash flipped up underneath the edge of the refrigerator and got stuck. And so he got to the end, and yeah, he gets mad pretty easy. So hopefully, this will save in there. We'll go to, have you guys opened the group meeting quiz?
I have not yet.
No, I haven't.
Okay. Are you still working on the prep for it?
No, I'm just trying to figure out how we can copy the data over. I'm not finding anything.
I know, it's so, see, I looked and it just says method 2 for copying a formula into multiple cells and pasting.
Yeah.
With formulas and setting. Okay, you guys are going to hear a video probably.
Okay.
Okay. Oh my gosh. I can't even understand this guy. Can you hear it?
A little bit.
Oh, okay. I got to try that. Hold on. Let's see. I didn't even realize that. I guess you can right click and you click move or copy, create a copy, and click OK. Let me see if that worked. Oh, I'm going to finish watching it.
Good.
Oh, this is not fun. Oh, that's what I'm doing. It's creating a copy inside
Excel.
Inside Excel, yeah.
Mm.
So that's not what I needed to.
Oh darn! There's another exam after this one. I was hoping this was
Like
the
next
last
week?
one. I don't know. I was just looking at my grades. I was finally getting around to that. Oh, good. My grade went up too.
I wish my grade would go up. You guys probably all have A's, right? In math? In this class?
I have a 93. So I think it's an A minus.
I have a 90. I don't know what a 90 is.
A 90 is an A minus. 93 is right there, like an A minus to an A. So mine's an 87. I'm like, seriously?
Well, maybe after this next test, it'll go up. I don't know.
It would be nice. I feel like I'm back in high school or something, freaking out about my grades. It's hard to let that go.
Yeah. Especially like, I don't know, math is, this class I have to like work the hardest in, I feel like, out of my other classes for my grade.
Yeah.
And I don't know, the more effort and time you put into it, the more frustrating it is when you don't get what you want.
Yeah. Well, I'll tell you, I don't feel like I have to put quite as much effort into this one as I had to put into Math 108.
Yeah.
Like Math 108 had calculus and trigonometry and stuff like that mixed into it. And I actually had to call my father-in-law over to help me a couple times because I just was not getting it.
Yeah, there were times I cried in that class. I was so frustrated.
That's why, and then you want to take a break for a while because you're like, I'm done with math. This ruined me for math, all of that. And then you get to biostatistics and you're like, I should have taken it the very next semester.
Yeah.
Am I right?
Yeah, that's what I did. I took it Math 108 last semester. So
okay. So it's all still fresh in your mind. And
I've been away from school for like a couple years, so.
Yeah.
And I don't know, math is fun to me, but I don't like it when I don't understand it.
Yeah.
Well, this whole class has been like learning an entire new language, like sigma and alpha and mean and z-test. And I mean, I remembered the z-score. And I remembered a little bit about the standard deviation. And when we did I can't even think, where we did the 60, was it 60 or 95 and 99%? I can't remember. Well, not like, well, yeah, the percentiles, but you know where I'm talking about, because we have our where it's normally distributed, and then there's a little section that's, is it 60 or is it 50? Brandy, you'd probably know. And then it goes to 95, and then it goes to 99.
I don't know.
Oh, come on.
I think I know what you're talking about, actually. It's like the 99.7 rule or something like that.
Yes, that one.
I don't know the numbers. I don't have those memorized, but I do know what you're talking about.
Exactly. I knew you knew what I was talking about.
Funny.
I struggle with the whole deciding which hypothesis test to do, or which.
Oh, yes. I did too, actually. I put a big star by that. And like, I need to study this.
If I have the formula and I understand the formula, I'm good. But the whole figuring out which one to do based on a story.
Yeah.
Yeah.
That's a struggle for me too. The flowchart kind of helps me with that, but I'm still not like 100% confident in my answers for them.
I'll have to look at that then, because I really struggle with those.
The first thing that it has you do is like classify whether it's quantitative or categorical. And then based on that, it'll show you like what your options are, which helped me a lot. But
oh yeah, the statistical flow chart.
mm-hmm.
Mm-hmm.
I tried to go to my dad for help because he's a retired chemical engineer.
Oh, cool.
And he's just like, I don't do statistics.
Yeah.
I'm gonna message Erica. She started recording us, so this is gonna be really long.
Oh, are we recording right now?
Oh.
Yeah, it says live, so it means that she's recording.
Oh,
I didn't know that.
We could start.
I didn't
know that either.
I'll just message her and tell her we'll wait for her.
We can always do another recording.
Yeah, let's not post this one.
Do you just kind of want to go over the review while we're waiting for, even though the answers are the same?
Yeah.
And
let's
then
go over the first couple.
Let's see. The first couple of them?
Yeah, like the hypothesis ones.
Okay, hold on. Let me. Oh, like number 8 and number 8? No.
I'm just thinking like number 1 through 9.
Oh, number 1 through 9. Okay. All right. I'm like, that wasn't hypothesis. Oh, I guess it was. Decide which hypothesis test to use. Okay. So I guess I'll just take turns reading it or something. We can figure out which one. But in an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level or high school, undergraduate, master's, and doctoral degree of people who managed successful startup companies in the United States and Korea. You want to determine if education level differs between managers of successful startup companies, differs between these two countries. Which hypothesis test would be the most appropriate for this analysis?
So I thought it would be chi-squared, but I'm not positive.
I initially thought it could be paired samples, but I was taking a shot in the dark, and then I came back to it and put chi-squared.
Okay. You want to see if it's different? Yeah. So that one would be 8. The human resource manager reported data from a recent involuntary reduction in force at her company. You're an attorney and want to determine if age discrimination was a factor. The company reported the number of employees in 2 groups, 40 years or older and 40 years and over 40 years. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test?
This one I said paired sample t-test.
And why did you say paired sample t-test?
Oh, I'm not positive, but I thought, okay, it'll be quantitative because it's age. And then the samples are dependent on each other because of how they're reporting it. Like if they're 40 years or younger, and then that will determine how they're picked for the second group of like who they can or can't pick. So that's why I thought it would be a paired sample t-test.
Let me read it again.
I was thinking individual sample t-test, but I could be wrong.
Like a one sample t-test?
No, it is, sorry, independent.
Independent sample t-test. Gotcha.
But I see your point.
It's not. I see where you would think that too. But like I would have thought more the paired in some ways, more for number one. Just because if they choose, I don't know, if they choose high school. Hold on, let me reread it. Like if they chose somebody who was startup company in the United States that was successful with a high school diploma, with just education in high school, it would automatically pick somebody who had a successful startup with somebody who only had a high school education in Korea. But maybe I'm.
I think number one is more. Wait, sorry, you thought it was the paired samples t-test for number one?
Yeah, but I mean, just because it would automatically have to pick somebody with the same education in the other country. Because they want to determine if the education level differs between managers of successful startup companies, differs between the two countries. So wouldn't they compare high school, or would they just compare what they had and then the proportions of it? So like this many people in Korea that had a successful startup had doctoral degrees, and this many in the United States had doctoral degrees. I guess we can find out when we answer it, because that's the only thing that I was thinking.
Well, I'm looking at that flow chart, and in thinking about it, I think it would be more. I don't know. I guess they have one sample and two samples for both.
This one seems like the data that you'd put in like a row column type thing of like you'd have
test of two.
United States, then you'd have Korea in a different column, and then you'd have the different rows of like high school, undergrad, masters. That's just how I saw it being set up, but I don't know.
Oh, okay. So you'd have like in the left side, you said you'd have like United States and Korea, and then you'd have the degrees across the top and be like, yes, like put the numbers underneath of how many.
Yeah, that's how I was looking at it.
Okay. Yeah, that makes sense.
Yeah, these ones confuse me.
Yeah, because then I'm like, oh, well, what about two sample t-test? And okay. I have to agree, those ones are really confusing.
Yeah.
So what were we saying for number two? Independent?
Yeah, I guess it depends on whether it's dependent or independent. One thing that I've noticed is like whenever it's a before and after, like it's always dependent. But this one isn't before and after. And then sometimes it can be dependent and sometimes it's not.
Well, they also, let's see, reported data from recent involuntary reduction in force at her company. An attorney wanted to determine if age discrimination was a factor. The number of employees in two groups, 40 over and 40 younger. They also reported the numbers in each group that were terminated.
I think it's dependent just because like
I kind of
it can't be random of like who they're choosing in the second group. It depends on who they picked in the first group to decide who they pick in the second group. But I've been before, so.
The other thing, which one is it?
Oh, Erica's on.
What about the 2-sample z-test for proportions? Because we're trying to figure out if it's fair, if they were treated fairly.
You can't do that though, because it's
the number of people who were fired out of the total number of people of 40, over 40.
If it was a proportion test, then it would have to be categorical. So, is it categorical or quantitative?
I think it's more quantitative.
Yeah.
But it doesn't ask for the number. It doesn't say number. It just says 2 groups, 40 and older and 40. Okay, it does. Reported the number, sorry, of employees.
Yeah. And then I think age is always quantitative.
Yeah, what threw me off is groups, both age groups.
Yeah, that was
treated equally.
I think it's quantitative.
So you're looking at a 2-sample t-test?
I think the paired sample t-test.
Yeah.
Now I'm talking about it.
Okay.
Erica, we're just going over like number 1 and number 2. So
okay.
Number 1, we put chi-squared, and
okay.
That was number 2. Number 3, we put paired samples, and that's all we've done so far.
Okay.
But did you have anything different for those?
For number 2, I had the chi-squared also.
Oh no.
And then if it would be.
Okay. Hold on.
Oh wait, for number 2, you did have the chi-squared.
Yeah.
Oh, okay.
Then I thought it would be.
Number 2, or are we talking? Okay, now I'm lost. Number 1 was chi-squared. Number 2
is chi-squared, just because number 1 was like, did you participate in this group's meeting? True or false?
Yeah.
Oh,
we're
sorry.
on the actual quiz.
Yeah.
Yeah, I haven't been submitting anything in the quiz. I was just going over the lesson.
Oh.
My quiz wasn't even open. I'm like, what are you talking about?
Sorry.
Okay, so number 2 we've chosen as chi-square then.
Yeah.
Yeah. And then 3, I thought it would be the paired sample t-test too.
Okay.
What we put.
All right, now I'm not yeah. Okay.
And then this one, I put test of 1 proportion for number 4.
You put what?
Test of 1 proportion.
Okay, that makes sense. Sorry, I was looking over it again.
You're good.
Project compared the effectiveness of 2 different combination logs.
And then for number 5, I put 2 proportions.
That's what I put too.
Okay. Are you guys good for number 6?
Sorry, I'm looking. All these confidence intervals.
I think I put individual sample.
For what's that?
6.
independent sample. Is that what you're saying?
Yeah.
I put confidence
not sure.
interval for 2 proportions.
Let me look.
I put independent samples, T confidence interval, but I wasn't positive either.
Yeah, I wasn't 100% on that.
Bank employs 2 appraisers.
You put paired or did you put individual? What did you say?
The independent, sorry.
Independent.
Yeah, and then I put the confidence for 2 proportions. I don't know. What is your reasoning for the independent?
I'm not sure.
I have to look back too because I did the review like a couple of days ago
Yeah.
on Sunday, I think it was. So
A bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval do you view most appropriate?
maybe
I
it
would
would
say
be
it's got to be paired. Don't get me wrong, but I'm thinking paired because if you pick, I'm probably wrong again. But so whatever the first, okay, so here's realtor A and realtor B or whatever, or appraiser A and appraiser B. So, and their first house. So it, the number for appraiser A will go under there, and then it'll automatically pair the number for appraiser B right next to it.
Is this?
Or is it like
well,
the before and after? Because it's a different, but it's not, those are 2 different people though. So, I don't know.
Is it quantitative or categorical first?
Well, it's a value, so it's got to be quantitative, I would think.
I would think it was
Because they're talking about
quantitative.
the value. I mean, it's 6 properties, but it's quantitative.
Okay, I can see that. So originally I thought it was categorical, but now that I'm looking at it, I would agree that it's quantitative. So now that it's quantitative, that kind of narrows it down to 1 sample Z, 1 sample T, paired samples, or independent samples.
Would it be the independent?
Oh, go ahead.
Let me think actually.
So if you do the paired, it'll show the difference between the 2, obviously.
Yeah.
That's
It'll give you the mean of each one and the difference between the 2. But then,
Well, and they both have to evaluate the same properties.
Exact same property, yeah.
It's like, I think it would be paired samples.
Yeah. I don't know.
I kept thinking paired sample t-test, paired samples, T confidence interval.
Oh, yeah.
Okay. It's hard to get those 2 separated. That's why I was asking. When I think of paired, I think of the father and son. So if it picks the son, then it's automatically going to pick the father for the height.
Right.
Right.
Okay. Okay, for number 7, I put 2 proportions, confidence interval for 2 proportions.
That's what I put too.
The what?
The confidence interval for 2 proportion.
Oh, okay, yeah.
Yeah.
Double stuffed Oreo cookies.
And then this one I said independent sample T confidence.
You put independent because we're comparing the two.
Yeah,
Paired, but I think you're right on the independent.
because I don't think they're dependent on each other. Even
No.
it's a 2-sample one, but they're not dependent.
So independent samples, T confidence interval.
Yeah.
Okay.
And then the probability of a type 1 error.
The probability of what? A type 1?
Mm-hmm.
That's what I had to for 9. Is that what you guys had to?
No, I was going with probability of rejecting the null, but in looking at it at the end, whether it's true or not doesn't make sense.
Yeah.
So I would probably go with probability of the type 1 error.
Okay.
And then for number 10, I put the third one, the probability of observing a sampled statistic more extreme than the one actually obtained, assuming the null is true.
Yeah, that's what I put.
Yeah.
It kind of threw me off at first because it just said more, and I think it's like at least or more extreme,
Yeah.
but more. So, but I don't know.
Number 10 is the probability sort of observing a sample statistic more extreme.
Yeah.
And the one actually obtained. Rewording it. Wouldn't you reword it as 95% of all 95% confidence intervals actually contain the true mean? On number 11. Because you want to reword it. It says, been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20.
I put the first one.
Okay.
95% of the sample means are between 10 and 20.
That's what I put
Okay.
too.
That's what I was thinking, but it just, because there's something somewhere and I don't remember where it was. At first I was thinking that, but what made me think the other one is that on some of, I don't remember the way that it was worded, but the answers, and you guys can tell me if you remember what it is, the answer was 95% of all 95% confidence intervals actually contain the true mean. Unless that's just the definition of a 95% confidence interval. But
I think there was one like that, but I think it said like 95% of all 95% sample means, or I don't know. I don't think you use the word confidence interval, but I don't remember for sure.
yeah, okay. So that's where it confused me. So just the first one, 95% of the sample means are between.
Yeah.
And then for number 12, isn't it 0.30?
Yeah.
Yeah.
Yeah, that's what I had.
And then 13, 0.046.
Yep.
Keep trying to add in
Keep adding an extra
a
zero.
comma.
14, I got 0.138.
That's what I got too.
What was 13 again?
13 was 0.046. And then 14, 0.138.
Yeah.
What is the margin of error? This is different than the one on.
Yeah, I just have written the confidence interval down for 14 or 15, I guess.
So it would be 0.032 because when you take the upper minus the lower, then it's adding it. So it would be 0.032, correct?
And then divide that by 2.
Oh, okay.
Then divide it by 2, so it'd be 0.016.
Yeah.
What was the confidence interval that you had for 14 then?
Negative 0.003 and then 0.029.
Okay, just making sure I had that right.
And so that'll be the answer for 16.
And 15 we came up with.
So for 15, you had negative 0.003, right?
For 15?
Yeah.
I put 0.016 because it's asking for the margin of error.
So.
I think it's off from the review.
Oh, okay, because I was like, the review had option.
Yeah.
So 15 was 0.016 then.
Yeah. And then the next one asked like the lower bound,
lower bound.
The negative 0.00.
Oh, okay.
That's
what I was
too. And then the upper bound would be 0.029.
Yes. And then it goes back to what we were used to. So number 18, we just want to know if it's different. So that's B. P1 equals P2, and then it's a not equals. It's moved around.
Yeah. So the first one?
Yeah, the first one.
Yes, that's the first one. I'm glad I wrote down what is the value? 1.458, right?
Yeah, 1.458.
1.258 is what you guys put?
458.
Oh.
And then 0.145 is the p-value, right?
Yeah.
And then we rejected it.
Yeah, so no.
So yes, I rejected. Is there sufficient evidence to conclude that the true proportion of the people? Yeah, there is sufficient evidence. So we rejected the null, right? No.
We failed to reject it, I think, because the p was 0.145, and then the alpha was 0.05, so p is greater than a.
That's what I had, was that we failed to reject it, so it was a no.
Yeah.
Okay.
So the last one.
No, failed to reject?
Yeah.
Okay.
And then 22, 6.580.
0.580.
Mm-hmm.
Did you originally come up with like 6.579?
Yeah, it just had you round it differently.
Okay.
Okay.
Just making sure, because that's what I came up with.
Okay. And then 23, 0.087.
Yeah.
That's what I got too.
And then no, the p-value is greater than 0.05.
Yeah, the fourth one, right?
Yeah.
This is different.
I mean, no, this one is different. So, so we failed to reject. So we have insufficient evidence to say that being, let's see.
That's an alternative. What was the alternative?
It's not independent, right?
It's not, it's not independent.
Yeah, the last one.
Okay, yeah.
Okay.
And then lower bound was 0.190.
That's what I got. Type in an extra 0.
And the upper was
Do you know what that one is on their review?
it's number 23.
Oh, okay, because I feel like I'm kind of okay. I'm good now. Sorry.
You're fine. It's
Keep
confusing.
switching the
Jump
yeah, it's
around.
confusing with the change of the questions and answers.
Yeah.
And
Yeah.
then what was the upper bound?
It'd be the 0.310.
Yeah.
Right?
So for 28, I got 1537.
$15.37.
Yeah.
I just lost Erica.
Oh no.
No, 28, that's finding n, right?
Right. So you do like
Yeah, so
the
it's like going back to unit 2 then, right?
I don't remember what unit it was. I think it might have maybe. It was like the z over m squared and then p minus p and then times 1 minus p.
Yeah,
I kept coming out with like odd answers, and I was using that. So like it was n equals z over m.
Yeah. So you put
Squared.
1.96 over 0.02
Oh,
and then
don't.
square that.
Okay, so how'd you find z? I guess because
But if we want the 2, don't we take 1.96 times 0.02 divided by, oh wait,
that's right. The z for 95% confidence is
Yeah.
1.96. I feel so stupid now.
Oh, Erica just said, so my computer just kicked me out of their group meeting. Are you guys still in it? Yes.
No.
okay.
That's probably where I was going wrong. I was trying to find the z, and it was simply the 95%.
But what are we supposed to multiply the 1.96 times what divided by?
So it's 1.96 divided by the margin of error. So they want 2%. So we do 0.02. And then,
Okay, gotcha. I was just looking at.
and then times it by 0.2 times 1 minus 0.2.
And that gave you the 1537, right?
Yeah.
I think my error was just the value for the z. I didn't have that.
Oh, gotcha.
It makes sense now. I forgot about the 95% and the z being 1.96.
Is there a way that we can invite Erica back into the group?
Yeah, you guys should on the top.
Oh,
There she is.
Oh,
Hey.
Hey, that was so weird. It like just kicked me out of the group hangout.
That is weird.
It didn't do that to any of you?
No.
mm-mm.
Okay. Well,
That's weirder because you're the one running it.
yeah. And it said like to start a new one and it let me get back in, but I don't know.
Yeah. What number did you leave off on?
I think
So
We're down
what
at question 29 now.
did you guys decide for 29?
Oh no, we're on 29 right now.
Oh, okay, sweet.
So
Wonder if it's because the broadcast was going for so long, maybe? I don't know.
maybe. I think the second to last one for 29, p equals 0.2, and then p is greater than 0.2.
That's what I had.
Okay.
Yeah, I had the second to last one too.
And then 30 would be the first one.
Yeah.
Mm-hmm.
Yeah.
I got 1.768.
That's what I had too.
That's what I had.
And the p-value 0.039.
Yeah.
Yes. That's what I had too.
And then the first one for 33. Yes, rejected the null.
Yeah.
Mm-hmm.
Yeah.
We are cruising.
Yes.
Cool. Let's see. Lower bound, I got 0.280.
Okay.
What was the lower bound again?
0.280.
I got 0.282. I might have typed or looked at it wrong.
No, it's just because it's round to 3 decimals, so you'd round that 2 down to a 0. Right? Let's see.
Mm,
It was,
I remember which one.
it was the blue data, right? My computer's going spastic.
I'm gonna do it over again. See. What Google Sheet did you put it in? What test?
I can't remember, and I didn't mark it down. My
Yeah,
computer
that's what
just
I'm
went
trying to redo it
spastic.
really quick and see.
Yeah.
I think I
Because
did.
it's a 1 sample, right? Copy.
I should have written that down.
Okay. Yeah, mine says 0.282 is a confidence interval, but it doesn't give, so it's a 1 sample t-test. So the only thing I can think of is, well, it rounds it automatically. So how would your guys?
Oh, that's weird. Hold on. Did you change? Wait, is the type of test greater than? Or will that change it?
I have it as greater than, but what?
To see if the score differs. So
So it needs to be not equal to then. So
that doesn't really change it. So mine says 0.282 now too.
Not equal
Which is
to.
weird.
Oh, and the p-value is really strange if you change it to not equal to. The p-value skyrockets.
I'm still trying to get the spreadsheet open again.
Oh, I think. So you have to change the null hypothesis to 0.295. And that changes the p-value, but my confidence interval still says 0.282 now.
For your lower bound, you got 0.282?
Yeah.
And then the upper bound is 0.293.
Yeah, I didn't get that the first time, but now that I'm doing it again, that's what it says.
And then the upper bound is 0.293.
These were harder because there was no there wasn't multiple choice to go off of.
No.
Yeah.
So
So
waiting on spreadsheets.
0.282, and the
This was
upper
one sample t-test, right?
Mm-hmm.
and then the degrees of freedom is 99.
Yeah, that's what.
Yeah.
And then the test statistic is negative 2.803.
Mm-hmm. 2.803.
Yeah, negative.
Negative 2.83?
03.
803.
Mm-hmm. And the p-value would be 0.006.
That's what I had.
Yeah, I did not get out the first time I did it, but now that I'm doing it again, that's what I'm getting. So.
Yeah, my spreadsheet's still being spastic, so. I did originally I have it written down 0.006 for the p-value and the same confidence interval.
Yeah, I got something way different. But now that I'm doing it, it's 0.006. Okay. So what would we conclude for number 39?
Wouldn't it be the true mean is different? We have insufficient evidence to say that the true mean is different than 0.295, right?
Yeah, I put the third one also.
Yeah, I put the third one.
Okay. I'll close out of that other.
For this one, I got 8.728 for the lower bound.
I did not get that far.
Oh, shoot.
Oh, no. So this one I put in a paired sample test.
Uh-oh. Hold on, guys. I think my Google Chrome just totally and completely shut down the whole window.
Oh, no.
Oh, no.
It's all right. I'll go back in a different way because I've got my Firefox open, which I should be doing it in there anyways.
There's so much data.
I think I accidentally hit the X button, and so when I was closing out of an Excel spreadsheet.
Okay, yeah, for 40, I got 8.728 also.
What was it for 40?
8.728.
Yeah.
Is my lower bound.
Okay.
And then upper 10.455.
The upper bound.
Get down to where you guys are at. Hold on just a second. That really sucked. Okay, for 40, what'd you guys say you got?
8.728.
8.728 is a lower bound.
Yeah.
Yeah.
And then the upper bound was what?
10.455.
10.455.
Yeah.
I really closed out of everything. And 42.
I think it's 22.446.
22.446.
Mm-hmm.
Degrees of freedom would be 40, right?
Yeah.
Oh, that's what I had.
And 44, I got like 2.79468 E minus 24. So basically just like 0.000.
0.000 for the p-value.
I think so. Because I got like a really, really small number.
Yeah, they're really long number. Yeah, no, I get that. I'm just opening up. We've done this one, the AM PM height.
Mm-hmm.
And then, yes, because we rejected the null.
Yeah, that's what I had too.
Okay.
Do we get more than one chance to submit on this?
I think so. I'm going to submit it and see
Okay.
how we did. All right, we got 38 out of 43.
Oh.
So we got some work to do. We missed number 3. And we missed number 5.
So let's go through and change them as we figure out which ones. We don't have to scroll back up. So number 3 we had as a paired samples t-test.
Yeah. Wasn't that the one we were debating on if it was the independent?
Yeah.
That would be 2, right?
Number 3, question number 3. So yeah, it would be 2 on our.
Yeah, that's what I originally had put was independent.
Okay, so let's
get to that one and see.
Independent for number 3.
We could
And then
try.
you said number 5.
Yeah, number 5.
That's the 2 proportions.
Oh man, these really get me. These darn hypothesis tests.
What did I put for that? That would be 4, right?
Yeah.
And then I had put one sample t-test for some reason.
Look at the chart. Would it be quantitative or categorical? Because if they're writing down the time it took, then it would be quantitative.
Yeah, so I would say it's quantitative because they want to know which one's easier to open.
Yeah.
Is it a 1 sample, 2 sample, or 3 sample? I think it's a 2 sample, right? Or maybe because if one of the locks turns clockwise and then the other turns counterclockwise, that's 2, right?
Yeah, because they're testing the locks and not the students. I think that's where I got confused on it.
Okay. Yeah.
But would it be independent or paired?